All right, so now let's get into the last video of this. Now, there's going to be more videos in the series, but I'm talking about the last of the first three. So in video 3, we're going to be covering the actual bot that is doing the work of generating this. So the procedural nature of what's actually happening here, excluding the storage, excluding the specific prefab type and managing object for that prefab. So in this case, right up near the top, I have bots and I have ground bot. This is the bot. This is the procedural generator or the tool that I'm using for this. And it's really straightforward. You can see what it's paying attention to, the position, which is an integer space or integer world space. But then we also have a reference to the cube that it's wanting to use. And then I have the speed at which it can create and move, which is really the frequency at which it can move to another cube or the frequency at which it can create another cube. And then finally, I have camera cushioning because, quite frankly, if it just moved instantly from cube to cube, that's what it looks like. And that's pretty jittery, especially when it gets close. And I don't like that. So we're going to go back to like 0.1. Oh, 0.1 is going to be too slow. So let's just go to 1. 1 seems pretty maintainable. You get to keep track of where the stuff is. Now, there is an important timing issue. I mentioned one of the previous videos, and so we want to make sure that we can see how this generation works. That's kind of vital, especially when you have multiple sets of these operating on top of each other. You want to see how they work in conjunction with each other, and when you get to watch them happening, aside from just being kind of fun and cool to look at, it also means that we get to witness and experience how that is actually being written out. And that gives us a lot of information for actually designing our code. Because this is producing the feel of how this island might look or how this landmass might look. So if I pause this and I zoom out, we've got this shape right now. And we can decide whether or not that works. Are the shapes that we've been getting, do they work? Are there things that we want to bring out of this that are not coming out now? And right now, whatever. I'm happy with this. I don't have a reason to do anything else. When I get into some of the other later systems, like adding mountains or water, then I'll probably have more concerns. Okay, so let's get into the code. This is pretty lightweight. You can see it's less than 85 lines of code for this entire script. So let's dive in. First thing is you'll notice I have these grouped together. I don't have a selection of public and private because, quite frankly, I don't care about that. This is grouped together in a logical reason. The cube prefab, the position that we're paying attention to for putting a cube prefab or going to an existing cube, or the positions that we are investigating for placing a cube prefab, those are all directly related to each other, so it makes sense. They're just right there. I don't care that one is public and one is private. If I want to go manipulate this, they're all grouped together. That makes it straightforward and easy. Then this also does a few other things inside of here. So we have our speed management, or how fast we can create and how fast we can move. And then we have the camera conditioning to keep it a smooth movement on the camera. So this is actually doing quite a bit. The camera movement will likely be split off into something else later because we're going to want to track different things. And we'll want to decide on that. And for right now, there's only the ground bot. No reason to create an additional system yet. Then we get into horizontal slices, which I'll cover in a little bit, but it's going to relate over here to the position. You'll notice that there are 8 fields here, 4 by 4, and there's a capacity of 8 here. We'll get into this in just a moment as to why. All right, scrolling down, update is pretty straightforward. There's only 3 key functions in here. Update is the first one where we are checking the time, and if enough time has passed, we will move. If enough time has passed, we will create. And every single frame, we will try to move ourselves to whatever new target position we're paying attention to, whatever block we just added or block we just moved to. That is going to be our current position, and we are going to keep lerping this target towards that position at whatever speed we set up with the camera cushioning. And then, of course, we tell the camera just go look at that target. That's our update function. Pretty straightforward. Calls the move, calls the create, and that's it. Okay, so the move function. First thing we're doing is taking the positions and clearing them. And then we are going through every vector3 int offset in a horizontal slice. So this is the horizontal slice. So what does that mean? What is this horizontal slice? We're dealing with 3D space in integers. So basically everything is this cube, this cube of a 3 by 3 to get all the adjacent pieces. It's 3 by 3 by 3. Technically -1 because the center object, we're talking about adjacent to the center. All right, so inside of this one, you can see we have all of these offsets in here except for 0, 0, 0. This is basically just a set of offsets. Once I'm in here, I'm checking through every single one of those, and we're taking our current position and adding the offset to it. So wherever we are, one of these will be -1 away on the y and -1 away on the z. One of them will be -1 away on x. One of them will be positive or 0 on z. So we're basically just getting those adjacent positions. At least if we're checking on a block level, then it's 1 away. Even though it's slightly more when you look at the diagonal angle or the diagonal distance of it. Okay, so anyway, we're going to just take that position, that new position in offset, and we're going to check to see if a cube exists there. We're going to call on that hasPosition function. And if a cube exists, we're going to add it to the list of positions that we could potentially move to, because this should be clear at this point that a rule exists, or we're using a rule that we can only move to a space where there already is a cube. All right, so that's in there. Now, one of the other reasons that there is an alternative I could have used here. Rather than using a for each statement and having an array, I could have used for int x and for int z, looping through each of the potential positions, but then I would have had to put an if statement in to check every single one of those iterations if we were at 0, 0, because we are ignoring 0, 0, because that's where we already are. Or we could just process 0, 0, 0 and include that as one of the potential positions that we're moving to. Of course, it would return a 0 anyway because something already exists there. Oh, wait, no, that would work because, yeah, it would think that we could move there, and so it would just stand still, which is effectively useless to us anyway. Plus, when we have the integers that are returning in that, in order to do this, we'd have to create a new position and create that int vector position. So we would need to have the integer memory and then create the int vector memory. But in this case, we don't need to create those extra integers. We've already got an int vector. We can just use it, and that's already existing. And I don't know if it works this way, but I'm assuming that when I'm doing my addition inside of the parameter value being passed in, that it doesn't produce it locally and copy it, that it actually produces the new piece of memory of where that's going to in the stack and then does the addition there. Because then it wouldn't need to produce the extra position, the new position offset combination where it generates a new int vector 2 or int vector 3. Now, I don't know if it works like that, but if I were designing the compiler that works with this, that's what I would have done. And I can't think of a reason why I wouldn't. Anyone who might know otherwise, please comment in here. That would be a pretty cool thing to learn. All right. Anyway, so if a cube already exists there, then we can move there. So basically, we're going to take any of the positions it found that we could move to, and we're going to pick one at random and just set our current position to that. That's it. Our move is done. Next, we're going to do almost the exact same thing for create, except instead of looking for where there are cubes, we're going to look for adjacent positions where there are not cubes. So again, we're clearing out the positions right away. And then we are going through every one of the horizontal offsets in the horizontal slice. We're going to check hasPosition again, but this time we're doing it with not. We are saying if there is not anything at this position, then we are null. And if we are null, then add it to this of places where we could create, because it's null space, so we can create something there now. If there was nothing, we just exit right away. But otherwise, we now set our position to one random choice within there. Now we're going to create a new cube prefab at that position. We're going to set the position inside the cube because nothing else is doing that. So we set that position, and then we add it to the cube system. Now, a couple things to call out here as well. you'll notice that I'm passing in position, which is it is a vector 3 int. It is not a vector 3. Like I said, the implicit conversion works, so you can just pass it in here without casting it. Second thing is, you'll notice cube prefab is actually not a game object, yet I'm instantiating a game object off of it. And that is because instantiate is intelligent enough to recognize that if you give it a mono behavior, that really only gets associated with a game object. So it looks at the parent or associated game object and generates that instead, returning the cube. Because I think I may have mentioned it before, but for the prefabs in this, it's particularly important to start thinking of your prefabs as you typically have a central control script inside of it that manages how that prefab operates. And that's what you typically want to interact with. Not all of its subscripts. You don't want to know about the structure of data inside of it. You don't want to have to look and say, grab this game object, get its child, find this by name, get the tag, etc. You don't need to know any of that. You shouldn't know any of that. It makes it very challenging for designers to be able to build anything because now you have this disconnect between programmer and designer. So in this case, we create a script that manages that for us, and that is our interaction point and all we care about. And so rather than have game object, I have cube. I instantiate the cube and it generates it for me and I'm happy. Okay, and that is... one other thing, the capacity in here. Since there are 8 potential horizontal slices, that means that for the maximum number of positions I can move or potentially create would be no more than 8. It would be 8 at max. So I just create a list that has an int position that is maxed out. Now, in this case, this means that I can just use the add function. I don't need to add extra code to manage the index positions or clear memory out. It just has the functionality built in. But it is also my belief that on an array, or on one of these, when you, one thing that I know that happens is that when you set the capacity, it will actually it'll allot that amount of memory right away on the array. And then once you exceed it, it doubles it. So if I went to 9, it would create 16 pieces of memory and then copy them over from the 8 to the 16, plus adding your 9th one in there. That way it can extend without having to constantly readdress memory and only doubles as necessary. So if you understand capacity, because if you think about it, like let's say that you had 100,000 objects that are being stored in here, or 100,001, because let's say you're adding 100,000 to demonstrate something, but you also have the prefab instance that's being stored or the central one that starts it off. So you technically have 100,001. Well, if you generated this with a capacity of 100,000, but you have 100,001, you now have 200,000 blocks of memory allotted for this. So yeah, there's some taking advantage of how much is there is valuable. Now, it's also my belief, and I'm not positive on this part. If someone knows, please answer, comment in the video. But if I were generating the compiler's work for this, when we say clear, I would assume it would erase that block of memory and rewrite it. And so once it rewrites it and just erases it all to 0, it's got the same memory. It didn't need to instantiate a new chunk of memory for this. It's already still using the same capacity that it left off with on the last time. So I would like to believe that it does that. If not, then we don't have that performance gain, but maybe there's reasons why it wouldn't be a performance gain. Any explanations on that, please add. All right, that's it. That is how this system works and generates all these cubes. As we go on in the video scripts, we're going to be adding different types of things like potentially mountains, water, holes in the ground, building structures, pathways, pathfinding. And I don't want to just be procedural generation, but also talking about the architecture of the game, the patterns and choices that I make into it, the performance expenses and considerations towards that, what areas I take flexibility where a lot of places consider default style guides that you need to do in another way. And then when I break my own rules and when I stretch beyond or say that we need to put standards in place that enhance and go up to the more common standards that we see. All right. Hopefully you found this video. Hopefully you found this video useful. I'll talk to you later.